This is Ken Forrester, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day and welcome to Momenta Digital Thread podcast series. Today, I'm greatly pleased to host Duncan McFarlane, Professor of Industrial Information Engineering at University of Cambridge and lead of the Shoestring Digital Manufacturing program. Duncan is Fellow of St. John's College and Head of the Distributed Information and Automation Laboratory within the Institute for Manufacturing. His work involves the development of manufacturing automation and control systems, and more broadly, the use of digital systems across the industrial supply chain. He had to start at BHP in engineering and research roles before joining Cambridge in 1995 as a lecturer in industrial automation systems. He was appointed Professor of Service and Support Engineering in 2006 and Professor of Industrial Information Engineering in 2011. Duncan has co-led key industry initiatives, including the Auto ID Center, the Innovative Manufacturing Research Center, the RFID program, and most recently, the Digital Manufacturing on a Shoestring program. Notably, he won the RAE Presidents Award for providing industrial engineering support to local hospitals managing the COVID-19 epidemic. He is also co-founder and chairman of RedBite Solutions, an industrial RFID and track and trace solutions company. Duncan, welcome to our Digital Thread podcast today.
Ken, thank you very much. It's a pleasure to be here.
And a pleasure to have you. You have a very impressive background, and I'm happy to say you and our backgrounds are woven at more than one occasion along the way. And so I've long awaited to finally be able to have a good conversation with you. And thank you for launching this digital manufacturing on a shoestring program, because I think it was the perfect topic to have today. So, we call this the Digital Thread podcast. And I always like to start with the question, what would you consider to be your digital thread?
Yeah, I've been working industrially since early 1980s. And as you said before, I began in the steel industry. And it's interesting that we talk about digitalization being new, but actually, even back in the 1980s, industry was pretty digital then in a perhaps more rudimentary way. And so I began doing the hard yards, trying to deploy IT systems and new algorithms and ideas within steel plants, and sort of segued into the aerospace and, in fact, space industry, working on robust control in the late 80s, working with BAE Systems, for example, and then went back into the steel industry. Having learned how to control machines in my PhD, found that there weren't any really hard machine control problems in the steel industry. And so I sort of moved out of that and got more interested in how you automate the whole material flow through industry, particularly steel making. I left there in the mid-90s and moved to Cambridge and took some of the ideas that I'd worked on in the steel industry, which was about how, this is the early 90s, we were looking at how to improve industrial control using AI ideas, and particularly trying to understand how to use AI to help manufacturing operations manage in the face of disruption. And that was really interesting. And AI was probably pretty rudimentary in those days. And then in the late 90s, I got involved through a few eccentric discussions in the area of RFID, working with MIT, as you know, on something called the Auto ID Center. And RFID, radio frequency tagging, was actually a little bit boring by the sound of it to me, because it was just about having an electronic version of a barcode. But I did see a way to connect it into some of the AI work we've been doing, and that was really interesting. And we had a huge program that led to the worldwide rolling out of RFID in industrial supply chains. And I span out a company, RedBite, which went on to do all sorts of interesting things. It still does, still running in the information tracking and in the Internet of Things space. And in fact, that program, the Auto ID Center, launched the phrase Internet of Things, which actually the chap that did it, a guy called Kevin Ashton, who was at Procter and Gamble, it was way ahead of its time. I don't think it really kicked off till the late 2000s. So from then, I took a lot of the ideas we'd worked on in manufacturing, and as you said in your introduction, worked in services. It's very interesting just understanding the engineering role in services. I got caught up in construction for a while, done a lot of work in logistics, and more recently in healthcare. So other domains using similar tools. Interesting thing, most of those domains are just slightly more customer focused than manufacturing often is. Then in mid-2010s, Industry 4 started to arise. And actually, Industry 4, to begin with, I was a little bit grumpy about it because I felt like it was corralling together a lot of things that we'd all worked on for a number of years. But actually, ultimately, I'm very grateful because it kind of took a lot of the advanced notions, the research that worked on, and put them into an industrial context. But that led, because of some of the challenges in Industry 4, for small companies, it led us into the Shoestring program, which is trying to do really simple things for small companies with digital solutions. So that's my thread. I don't know if it's a thread or a weave or just a jumble. Anyway, that's it.
It sounds like a complex fabric, as in a textile, because there's a lot of threads there. But I have to laugh about your grumpy phrase there. It comes back to this idea of standing on the shoulder of giants. And so in some sense, you couldn't have had Industry 4 without a lot of the really pioneering work that went on to build that infrastructure. And in some sense, as you said, you're putting on top of that the digital manufacturing or shoestring program now. So it's interesting how we continue to build these things up over time. One of the things I must say I really appreciate about you and your career is traditionally we tend to bucket practitioners/operators and academics and, take your pick, right? But in your case, you've had a footing in both these. You were actually quite an accomplished practitioner at the time you decided to take on a kind of the professorial mantle, if you will. I'm curious, what ultimately inspired you to begin teaching?
Yeah, I mean, and I should say that I began at BHP when I was 16. And so although I was there with them for 16 years or so, 14 years or so, actually I left them by the time I was 30. But it really had a big impact on me and certainly something that's never left. But one of the challenges I had there was I got to know the steel industry really well. And although BHP also had minerals and petroleum interests, a lot of their R&D was focused around steel at the time. I should have also add BHP, now BHP Billiton, has more or less no steel industry whatsoever. But I had a lot of experience in one industry. And it's interesting, what inspired me to begin teaching wasn't wanting to teach. In fact, I was attracted to the Cambridge role because it presented me with an opportunity of working with a lot of different companies in different sectors and understanding the different challenges they felt. In fact, I actually began my time in Cambridge after having played golf with my old supervisor, who was in a different part of the engineering department. And he said, well, look, they're interested in this manufacturing group in recruiting you. And I said, well, what do they do roughly? And he said, they drive around the country a lot in minibuses looking at factories. And for me, that sounded fantastic. So I jumped at that. But also, I guess I also saw there was an opportunity to perhaps challenge some of the conventional approaches to engineering teaching. And within the manufacturing part of the engineering department, they were already doing some of that, really driving a much more practical orientation into the way students were educated, whether it be through student projects out in industry, getting industrial speakers to come in and talk. We have an automation lab where we give students a lot of hands-on activities to build industrial systems. And for me, that seemed a really nice flavour. And it also, seemed to address a lot of the areas where I thought had been challenging for me as an undergraduate. And I guess that did inspire me to get more involved in teaching, trying to see if I could get more students going out working in industry.
So you are a professor of industrial information engineering at Cambridge University. Can you tell us a little bit about, I guess, really what attracted you to this field, but more importantly, what is industrial information engineering versus some of the, let's say, more common traditional industrial or information sciences?
Yeah, well, it's an interesting question. When I got this chair, I sat down with the head of department, and in Cambridge, it's left to you to decide what the title of your chair is. And she said, what do you want it to be? I'm never good at these things. And I said, I don't know, automation engineering, information engineering. And she said, well, we've got professors of information engineering already, and they kind of do lots of stuff with matrices and maths and do really clever bits of analysis. And it didn't feel that was me. It might have been me 15 years earlier, but the word industrial was missing. And so what I said is, I'm not sure if I'm too worried about the rest, but I want the word industrial in my title. And so very much the focus was on how do I bring information or automation engineering developments into industrial use. And in fact, in recent years, I actually had to do interviews for chartered engineering status. And I remember in one of the interviews, the IET panel in the UK said, we've been looking at you. You're not a conventional sort of academic, are you? And I didn't quite know how to take that. But in the end, I decided it was positive. And I guess what had happened for me is that my industrial experiences significantly influenced the nature of the way I did R&D. And I mentioned that when I had done my PhD, I worked on some very interesting algorithms for robust control of satellites. And going back into the steel industry, was told there's only one hard problem of that sort in the entire company. But there was a lot of other complex problems that ought to be looked at. And I also talked to a colleague out in Australia who'd worked on radar. And he said, actually, these algorithms you're working on, they're really good. But to be honest, they're less than 5% of the whole solution. And so I kind of got interested in is what was that other 95%? And I built my research group around that and made it very much problem and solution driven. Even if you go to the website now, which has changed in 30 years, but it's very much focused on bridging the gap between academic developments and industrial need. And I have this thing called the DIAL hamburger. DIAL is my research group, Distributed Information and Automation Lab. And the hamburger, the top of the bun is industrial practice, the bottom of the bun is academic development, and the meat in the burger is that interfacing piece. And we work very hard at being good at that interfacing piece, in drawing problems and issues down from industry and then moving solutions back up once we've managed to achieve something that matches the industrial need. And, so that's the other thing I've done within my group is made sure that every project involves working with a company. And that's, been pretty consistent over 30 years. And that actually forces me, my research team, my students to be able to not only to work on clever solutions, but to keep them simple and articulate in terms of the needs a company might have. And that's been a really rewarding thing to have achieved, because I think every student that I've had that's been, sometimes forced, mostly willingly went out into a company, has gained significant life skills as well as research skills from that process. And, actually, we've worked on, over these 30 years, there's been three dominant issues that still sit there as the core thrust of the research group: smarter automation, making better use of information, and managing in the face of disruption and change. And none of those look like going away anytime soon. And perhaps the last thing to say on this is, if I began, as I said, looking at AI and how its role would be in developing solutions for industry, and if the shifts occurred, perhaps over the last couple of years, it's still looking at intelligence and AI and these sort of ideas, but perhaps less so within the solution we deliver, but within the approach we use to build the solutions, which has been a rather interesting spin for me.
I was actually going to ask you about what's changed during your tenure, but I think you did a great job of already describing that. It's interesting that the starting point for you was AI. And now here we are again in, post the, I guess you might call it AI winter. And all of a sudden now it's become extremely hot topic again, especially relative to optimization of industrial processes. And so perhaps you can go back for a moment. You mentioned something about what really is different is the approach. Maybe you can say a few more words on that, because I'm kind of curious on that.
Yeah, well, so particularly with our work with small manufacturers as part of this shoestring activity that you mentioned earlier, we realised that what we need to deliver for a small company with very limited resources and skills in the digital area is a solution that is as simple and straightforward to understand, to deploy and use and maintain. And on average, the sorts of needs that small companies have actually don't immediately lend themselves to AI. I think there is a future role for AI once companies become more digitally enabled. But the key for us right now is we want to be able to deploy these solutions as easily as possible and help organizations do that deployment. And so actually the AI opportunity there for us is making not the solution itself simplified or enhanced, but actually the solution process, like the process of acquiring the solution, of customizing it and building it using AI in those stages. And I think that's very much in line with the generative AI approaches that have been evolving in the last couple of years, which is much more of an advisory tool than what I'd call a closed loop AI tool. I was going to just make one other comment about if you talk about shifts, Ken, for me, the other fundamental thing that's occurred, well, apart from, say, the internet, I should mention that as well, but the fundamental thing when I began is that IT was kind of a service function within a business. And it was a kind of a minor service function it was separated from engineering. And actually in the 2000s, many companies sought to outsource their IT. Whereas today, IT and information, and as a result, AI as well, are really a strategic imperative. And I think for me, that enabled by internet has been a major shift across my working career.
Yeah, it's an interesting thought. IT, I was always described as I came up with in both manufacturing and IT. IT was keep the lights on, right? That was the major focus there. And of course, you get an OT side, it was all about efficiency, productivity, safety, everything that, goes with manufacturing processes. And now all of a sudden we change it to digital and it becomes a core competency, if you will, and a competitive one at that is driving many companies. We interview a lot of chief digital officers, and it's interesting to see how they're really changing a business, but it's not with necessarily just off the shelf technologies. It's the application of catalytic technologies, if you will, toward business transformation, change, right? And business models that go with it. So you're absolutely right. Hadn't quite thought about that metamorphosis where we all of a sudden saw it so critical that we weren't outsourcing it anymore, but it certainly has happened along the way. Let's go ahead and drill down on digital manufacturing and a shoestring. This is what really attracted me to this conversation. And so you're looking at how low-cost, readily available digital technologies can be implemented to support growth and productivity in small and medium-sized enterprises, or SMEs, as we like to call them. What inspired you to create this initiative?
Well, so I mentioned one of the inspirations was this grumpiness about Industry 4, actually the unfair grumpiness, but also I went to a lot of Industry 4 seminars, workshops, events in the mid-2010s and found myself at various events talking to people from small companies. And the overwhelming message I got at that time was that some of the pretty shiny, exciting new options coming through in Industry 4 had limited resonance with small companies. And, the comments were along the lines of, oh, gosh, I'm sure I'll never have enough money to get involved, work with those sort of systems, or we don't have the digital capability in-house to engage with this type of development. So there was the limitations that small companies were seeing was one of the issues. And actually, I also did do a bit of digging because I thought, well, small companies, how many are there anyway? Maybe not that many. And the astonishing thing for me at the time was finding out that in the UK alone, there are about 200,000 small manufacturers operating, and they had an average number of employees of around 2 to 3. And most of them, in my sense, were sitting at the bottom of what we call the digital pyramid. So, the digital pyramid has the big players at the top, another set of medium-sized businesses underneath, and then everyone else underneath that. And those organisations were a little bit disenfranchised from these developments around Industry 4. So that was a key factor. A second thing was the growing understanding and working with my students helped this a lot, is there were very low-cost systems and components becoming available. There was open source software becoming more professional in its way of operating and development. And more generally, there was a shift in balance in developments in digital systems outside compared to inside the industry. And so that actually looking outside industry for some digital tools might have been a good pathway. And then finally, I had a realization that actually our next generation of students and apprentices, trainees, etc., are all going to come forward with great hands-on digital skills, but possibly not the digital skills we expect of industrial engineers at the moment. And in fact, I had a student that came to me one day and said, I want to build a smart fridge for my project. I said, that's a 6-week project. Are you kidding? He said, well, I think I can do it. I want to do something else in the project as well, but I think I could do it in 2 to 3 weeks. I just need a GoPro camera and a Raspberry Pi, a temperature sensor, and, get some AWS access. We should be able to do it. Anyway, he had a go in his 6-week project. He didn't quite get there, but he then spent the rest of the summer fixing it up. But I was shocked by the speed that he was able to put this together and thought, surely we must be able to do better than that for our industrial companies we work with. So Shoestring kind of was spun out of those different notions into how can we do something very low cost for small manufacturers and keep it really simple for them so they can just get started on using digital technologies.
So how is this Shoestring program organized, and how do the small to medium enterprises participate in it?
Yes, so Shoestring, as you said earlier, it's focused on low-cost solutions for small and medium-sized enterprises. We really try to give companies an end-to-end approach in that we help them not only take a solution on board, but they get involved in specifying, designing, deploying, maintaining the solution. And so that our goal is really to get simple digital solution into as many SMEs as possible and help them kind of step up on that digital pyramid thing that I mentioned earlier. And we also noted when we were talking to companies, and this is kind of really important for us, is that although there are lots and lots of small companies, actually many of them want the same thing. And it's often very simple. And just to give you an example, the number one bestseller, or the one that comes up almost the most, is something called a job state tracking system. And it's basically an answer to the question, where is my job in the factory at the moment? So the sort of thing that's in most big companies. But in a lot of small companies, they don't have any sort of simple system that helps them to find stuff. So that's the sort of thing Shoestring does. And we got started as a program in a UK-funded research project, and the Engineering Physical Science Research Council funded it. And it allowed us to build a design approach because in some ways, we're doing what people have already been doing for years as hacking, and we're just adding more systematization to it. So we built a design approach, we built tools, we built solutions, did some pilots. And on the back of that, we received some funding to launch a Shoestring business unit in 2022. And it's a not-for-profit, which is overseeing and developing the approach and overseeing the deployments, for example, through regional contracts in the UK and overseas, through research programs, other research programs, through direct sales, and increasingly starting to do it through third-party providers as well. So our aim is not to be the organisation that deploys hundreds of thousands of solutions. We want to enable other people to do that.
So what have been some of the notable results you've seen? And maybe another way to think about it, what has surprised you the most about the program's impact?
Yeah, well, it's interesting. I probably had 50 research grants in my career, possibly even more. And you start each of them thinking, this is going to be the big one. And often they're not. So a surprise was the company engagement and enthusiasm with the research project from the absolute word go, to the point that 1.5 years into the research project, a group of the companies came to see me. And bear in mind, we're in the middle of COVID when we were running the initial part of the work. And they said, you need to have a plan for what happens when the research project ends. I'm going, you've got 1.5 years to go, guys. And they go, yeah, you need a plan. And that was, I guess, the big surprise was from the word go, this is what companies wanted. We were pushing open door whenever we talked to people. So the program was meant to do a couple of pilots. We ended up doing 20 pilots, most of them run through COVID lockdowns, deployed over the phone using enthusiasts in the companies. Almost all were totally successful. People just really happy, not only with the result, but actually being involved in the result. And I think there's a side benefit that's also been a surprise, which is the digital skills and training impact that have come through, whether it's for the end users or for organisations getting involved in deployments. So to date, we've deployed about 100 shoestring solutions or shoestring-based solutions. As we continue to build the tools and we streamline our approaches and we're getting better and more capable, and we're working a lot on our modular reusable design approach. And interesting fact, we've got about 8 modules we've developed which cluster basic technologies, and we use them over and over again, much more than we ever thought would be the case. Another surprise, I guess, is the fact that we started the program and a number of the companies that I work regularly with, Boeing, Exxon, Amazon, Unilever, all came to us and said, I don't get it. You won't let us join this project. We want to be involved. I said, but this is for small companies and it's little low-cost solutions. Why are you interested? And they said, we are interested. So we've subsequently done quite a bit of work with big companies who have different approaches, different ways of where they want to use low-cost solutions, but they're definitely keen. And then we also had strange calls from around the world, including, again, another one in the middle of COVID from a guy in Perth in Western Australia saying, a chap called Andrew Duff, he said, we're really interested in shoestring. We want to start a program in Western Australia. Will you support it? So, and that we've had follow-ons in Egypt and New Zealand and South Africa. So lots of other international interest. So it's been a really exciting 5 or 6 years since we kicked off the program, and it seems to continue and continue.
Look, it's a very commendable program and interesting how it, in some sense, very insightfully saw the reshoring initiatives, deglobalization initiatives, some might call it, that are all of a sudden creating much more demand for, digital, if you will, capabilities onshore, local, if you will. I think before the call, we were talking about local optima versus global optimas. And certainly, I think it certainly comes to mind. So, and it sounds like you have been doing a great job already scaling it. I'm curious if somebody wants to get involved, how do they find out more?
Well, digitalshoestring.net is probably the first port of call for information there. And as I say, we're now directly selling solutions from that website. But again, what we've been trying to do, and this is kind of linked to your comment about scaling, Ken, is we know we can't, if we want to deploy at the scales we're interested in, which is thousands and tens of thousands, it's not going to be our team that does that. So we're interested in building regional capabilities for deploying shoestring solutions and finding people in a region that are able to do that. And so one other way a lot of organisations are getting involved is working as a cluster in a region. And we're, for example, doing a program down in Cornwall in the UK at the moment where a local engineering organisation is doing deployments, working with the shoestring team in Cambridge. Equally in the Western Australian activity, there's an engineering company out there working with us. So our interest in getting people involved can be through direct sales, but also through regional programs. And increasingly, we're starting to develop these third-party developer relationships as well.
It's excellent work. And I must say, it's really interesting to see how organically you continue to grow it. Again, very commendable. So as we wrap up, I'm always curious how you maintain your edge as a leader, particularly in digital manufacturing. Any recommendations you'd like to highlight for our listening audience?
That's an interesting question. My sense about maintaining an edge, if I've maintained an edge, would be not via conventional sources. What I mean is, if you read what's in the popular press or even what's in these regular academic journals, what you get is a linear progression in the way things develop. And I'm always interested in kind of left field developments. And I think why I like the shoestring approach is no one ever did any research into low cost before. Low cost is a kind of a taboo research topic because people want to build better functionalities, improve capabilities, but there's very little research on how to reduce costs. So I get inspiration from strange places. I mean, the company's not strange, but there's a kind of a massive underestimate in terms of the inherent capabilities of people in companies. I don't mean researchers in companies. I mean operators on the shop floor. Way back in the steel industry, I learnt that actually I could find out most of what was going on by talking to the guy that was running the piece of equipment I was trying to automate with him. I also find my students are fantastic at kind of flipping things on their head. And I gave the fridge example earlier on. They send you off in different directions than perhaps the directions we expect it to be in. Also, I mean, it's a bit weird, but I actually write poetry and do quite a bit of drawing and do cryptic crosswords. And they're strange left field areas of inspiration, but poetry is a very efficient way of writing. Cryptic crosswords, well, the great thing about cryptic crosswords is you always know when you get an answer right because they self-check. And I like systems that self-check. And my drawing is pretty poor, so I keep it minimal. And I think minimalism and simplicity has helped me. And perhaps, I'm doing quite a bit of work on history of automation. And at the moment, one of the things that's really intriguing me, and we mentioned this beforehand, Ken, is, there was automation before there were digital systems. And when I was looking at some of the early water clocks or the governors in steam engines, we were doing clever things in automation before we had digital. And there may be a time where we want to think about new technologies that aren't necessarily digital technologies. And I'm kind of trying to get my head around what that might look like. And final comment, perhaps I'm reading a book on the philosophy of logic. And in my mind, we're talking a lot about AI, but I feel like there's still a lot to come in the AI space. And perhaps we ought to understand a little bit more about logic and probability, perhaps, in a more articulate way before we start trying to harness what we can do with AI. So I don't know. It probably just says I'm not a conventional academic again, but that's where I get inspiration from.
Wow. I love the power of open-ended questions. Like we start with a digital thread when we end with this one, because you never know the answers you're going to get. And I think the last probably 2 to 3 minutes so described who you are as a person. And I'm debating, I'd love to do another podcast. Is it crypto crosswords or really, of course, the teaser you put out there on AI? And we'll know which one it's going to be. But what a great conversation, Duncan. Thank you so much for sharing this time and these insights with us today.
It's been really enjoyable. It's just been a great chat, Ken. I'd love to do another one.
Oh, and believe me, we'll put a point on the next one around AI because I think that we're just, as you say, right at the beginning of that revolution. So this has been Duncan McFarlane, Professor of Industrial Information Engineering at University of Cambridge and lead of Shoestring Digital Manufacturing. Thank you for listening. And please join us for the next episode of our Digital Thread podcast series. We wish you an impactful day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion. And as always, we welcome your comments and suggestions. Please check our website at momenta.one for archive versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.